So my topic is mixture models for intrapersonal data. And I would like to start with this kind of figure. Mixture models can be characterized as model-based clustering methods too. And it can be said that they are kind of between traditional person-oriented methods and then variable-oriented methods. And if we think traditional person-oriented methods, the aim is to classify individuals into subgroups based on pattern similarity, typically with some distance criteria, and there is no assumption of underlying statistical model. And in turn, in variable-oriented methods, such as regression or path models, another kind of models, typically the aim is to investigate often linear associations between the variables. And mixture modeling can be considered to be between these two. And its aim is to identify subgroups of individuals based on certain model parameters. That is, in mixture modeling, observed distribution, it's kind of composed of mixture of different distributions. That is, it's assumed that there are different subpopulations in the data. It's not enough to model the whole sample and fit one nice model to the whole sample and maybe variability around it, but there might be some subgroups that are very different from each other. And I will next present you some examples, some possibilities of mixture modeling to analyze intrapersonal data, and after that I will present one empirical example. And in notation, we use symbol C to refer latent categorical variable that includes k number of latent classes or latent groups. And mixture modeling, it can be applied to continuous variables or categorical variables for cross-sectional data or longitudinal data. And I guess one important feature is that researcher has to think what is the overall model that would describe the data. And as the next step, what parameters in this overall model are allowed to be different between different subgroups. That is, those subgroups are tried to identify based on differences in those specific parameters, quite often means, maybe variances, but also maybe regression coefficients. And here are some examples of different kind of mixture models. Latent profile analysis, factor mixture modeling, mixture factor modeling, regression mixture modeling, crowd mixture modeling, and so on. And also for categorical variables, there are possibilities like latent class analysis, latent transition analysis, and of course, these are just examples. So basically, it depends on researcher who knows the data, what's the best kind of model it can be. Basically, so it's possible to, well, I'm mainly now talking in M+ modeling context, what it is able to do, but almost anything is possible, any parameters that you can imagine. But of course, the principle of parsimoniity is usually in practice important. If you start with too complex model, then probably you will end up in the problem. So it's better to start with simple and add complexity step by step. Like for example, first try to identify subgroups based on mean differences, and if that seems to work, maybe there might be differences also in variances, and see what happens. And well, one thing is also that all these models can be generalized in multi-level mixture modeling. Empirical example that I will present you will be multi-level kind of example. And also multi-group mixture modeling is possible, like whether these similar kind of subgroups are found, for example, among girls and boys, and whether prevalence of these subgroups is same across the groups of interest. And here are some more graphical illustrations. In the upper figure, there is this solid line. It represents the observed distribution, but then beneath there are two different sub-distributions for group C1 and C0. And it might be that observed distribution is like this, but if you are lucky and if the means of latent subgroups are far, it might also be that you observe peaks in your observed data, which is, of course, in case you would like to apply some models that assume normality problematic situation, but actually it might signal that there are some subgroups in your data. And in this below figure, there is an example of latent profile analysis. There are two Y variables, and researcher would be interested in whether there are different subgroups in terms of patterns of these, in terms of means of these variables. For example, it could be academic achievement and motivation, or what is of interest. And typically, of course, I think mixture modeling is at its best if it can reveal something that you couldn't see by using variable-oriented methods. If you, of course, it's a little bit boring result if you find just high achieving, average achieving, and low achieving students. Of course, there is some variability, but then if you find like high achieving, high motivated, high achieving, but low motivated, and if you can find that kind of nonlinear patterns, then I think it becomes really interesting. And in this figure, when there are two Y variables and that line between them, it represents, kind of illustrates strong association between these two Y variables. But actually this association is due to the fact that there are these three subgroups in the data. And after this subgroup membership is taken account, then after that, these Y variables are independent from each other. This is traditional latent profile analysis. What it assumes, of course, is possible to relax this assumption if it is realistic to think that there is still, after you take account this latent categorical variable, if there is still something that these Y variables share. And still some more examples to illustrate the, well, now I find your pointer, that you can, of course, have more observed variables, in this case 5 Y variables, but then you can also have covariates. And in this example, it's kind of subgroups tries to identify based on the means of Y variables, but also based on this regression coefficient from X to Y. So it might be that this regression is stronger in the one group than in the other. And here below there is an example of crowd mixture modeling. It's thought that basic model is latent crowd modeling. You want to model, for example, development of academic skills across time, and you want to model the average shape of change across time, and then individual variability in the initial level and growth. But it can be so that this is not enough, that there is more subpopulations in the data. And in this figure, there is an illustration of frequency of heavy drinking. And this is actually a very illustrative way to get idea of your data if you draw your individual curves. And you actually see that, well, for some people, the drinking is clearly increasing, but for some people, it's kind of first increasing, then decreasing. Maybe after people go studying to university, there are some nice parties and so on, and then drinking increase, but then when they go to working life, then it again decrease. So in this kind of situation, it's not probably realistic to assume that only one curve could only one average development could tap the shape of change in the data. In this kind of situation, you probably need two different subgroups, and of course, within those subgroups, there can be still variability around the average curve of that subgroup. And about steps of mixture modeling, as when you carry out it in this model-based way, that you have statistical model in there, then these building phases are similar as in traditional structural equation modeling. First, specification of the model. This is really important that you select meaningful y variables in your model, and also that you carefully think about alternative overall models, because if you select wrong model and then you proceed on modeling, then it might be that you get strange results or unreliable results. So it might be good to try alternative ones and make sure that you first find good model, and only after that go on to mixture modeling. And well, then of course checking identifiability, estimation. Estimation you have to do separately for each number of latent classes. You first have to estimate the model in which you have only one class, that is the whole sample. Then after that you have two classes, you compare that to one class model, then three classes, you compare that to two class model, and so on. And then you get also some goodness of fit indices to help your decision. And of course, also content-wise interpretation is very, very important, as mixture modeling is partly, at least in its basic form, it's partly explorative method. So it's important that you have some theory that is guiding you through the process. I think in some newest application there are also some confirmatory approach has been combined with this, that it's possible to make some model constraints kind of a little bit limiting what kind of groups you are trying to judge, but basically I would emphasize theory. Yes, and then I guess two more slides before going to the empirical application. There are some alternative models to think about. And in this basic first model, this is basic latent profile analysis model. There are three y variables, and after accounting this latent categorical variable c, these y variables are assumed to be independent. But it's possible to relax this assumption. It might be there is still some associations between y variables after accounting this latent categorical variable c. And if you don't take account this variability, it's possible that you, for example, get too many classes according to fit indices. So although it can signal if it's very difficult to kind of end up to the solution that there might be something wrong in your initial model. Well, then there is a possibility of factor mixture model. In this case, it could be, for example, repeated measurements of achievement, motivation, and you kind of take into account this time dependency with this factor, but then you are still interested in those patterns, mean patterns regarding values of y. Or then it might be that you are interested in finding subgroups based on factor means. So three variables, very simple thing, but already now so many options. And of course you can empirically try all of this, what happens if you are not so sure beforehand what happens if you make this kind of change or that kind of change in the model. And here are then some alternative crowd modeling paradigms. And in this first, there is this traditional latent crowd modeling paradigm that we just fit one overall curve shape of change in the data and then allow individual differences. Well, then Negan's approach that we are interested in different trajectories, for example, in drinking across time, across age. But then after taking account these different trajectories, we it's assumed that after that, all the variance, what is left is just error. Or then it might be that there is also variability within these latent groups, and even if you would like to go further from that, you can of course relax that also, that in some groups there might be more variability than in the other, but of course it might also impact in that case about the average differences between group means, but basically anything is possible. But yeah, I hope that you got some general idea what is mixture modeling about. And next I would like to present you empirical application. And here is reference to this study. This is really available. And also statistical equations and M+ scripts are available in this paper. And first author is Kaisa Aunola, also from University of Jyväskylä, and also Asko has been in this paper. Well, first some content-wise background. So according to emotion transmission paradigms, emotions within families, especially negative ones, there is tendency that they spread and affect the family atmosphere and the interaction between family members. And well, it has also been suggested that some children might be more vulnerable to environmental effects than the others, for example, due to their temperamental features. But yet, the role of child's temperament in this emotion transmission, it has not been studied much. So in this study, we investigated the extent to which daily negative emotions of fathers and children are transmitted in the father-child dyad, and the extent to which children's temperamental negative emotionality influences these associations. Negative emotionality refers kind of biological tendency to experience strong negative emotions, or kind of increased likelihood to experience strong negative emotions in different situations. So I guess that the notion that some individuals are more prone to emotion transmission than others, in itself it calls for person-oriented approach. But still, if we think previous person-oriented research, only little attention has been paid for this. And as far as we know, this study is among the first that try to identify patterns of transmission between dyads or partners rather than patterns of individual characteristics. And participants in this study were from light study, and 149 children from grade 1 and their fathers. And there was a parental questionnaire in first grade fall, and also there was parental daily diary during 7 days in first grade fall. So parents filled diary every day, like there is always 1 day lag between different reports. And then mothers rated children's temperamental negative emotionality, and well, then also children's daily negative emotions were also reported by parents, and then fathers' reports of their own daily negative emotions. And in this study, we used both variable-oriented and person-oriented approaches to examine our research questions. And one aim was to compare these approaches and whether we get complementary information, and all the analyses were conducted using multi-level modeling. And first so-called prospective change model was utilized to examine the extent to which fathers' emotion on a given day would predict changes in their children's emotions from a given day to the next, and vice versa. And then as a next step, we added a random slope in this model to investigate whether there are differences between father-child dyads in the strength of this emotion transmission. And if there is variation, then we predicted it with child's temperamental negative emotionality. And here is within person model, or model kind of within these dyads. Looks quite familiar what was shown in the previous presentations. But our particular interest was that whether child's emotions predict father's later emotions, or father's emotions predict child's emotions, and then whether there are variability between these dyads in the strength of this emotion transmission. And it turned out that